to solving rational equations. Now the reason this is a rational equation is I've got a rational expression here, a second rational expression here, and in the middle we've now got an equation. So we're going to see a couple of different techniques here that we can use to solve this. The first one that we're going to see here is we're going to use cross multiplying. If we have just one expression equal to a second expression, we're going to simply cross multiply. So starting in this direction, I'm going to go 5 times the quantity x squared minus 1 equals 15 times the quantity 2x minus 2. I'll distribute and then, since this is looking like I've got a quadratic term and a linear term, it's going to be a quadratic equation. I'm going to bring everything over to the left side. So the 5x squared stays here. I'm going to subtract 30x, and I'm going to add 30. And that leaves me with a 0. So since all three of those terms, I can make them smaller by factoring out a 5. That leaves me with an x squared minus a 6x plus another 5 here. And now I can factor this. That trinomial factors into, let's see, factors of 5. I want 1 and 5, and both have to be negative. So now I'm in good shape here where I can set each factor equal to 0. Well, my first one, there's no variable there, so I don't even have to do anything with that. X minus 1 equals 0, and I have x minus 5 equals 0. Well, these last two are easily solvable. So I've got two potential solutions. But the key thing we have to do is check answers here, because sometimes with the rational expressions, we can have it go undefined. So I want to take the 1 and the 5, and I want to check 1 and 5 and see if 1 or 5 makes that 0. Well, right there, 1 doesn't work. 1 doesn't work on either side. So 1 doesn't work, and if I plug in 5, well, 5's okay. So what we have here is a situation where 5 is the only one that works, 1 doesn't. 1's called an extraneous solution. Okay, in example 2, a second technique we're going to look at for solving a rational equation involves using what we call a least common denominator to clear the fraction. We can't cross multiply here because we have on the left side two different expressions and then also one on the right hand side. So what we're going to do is pick out what our least common denominator would be. Well, from here I've got a 2x, from here I've got a 5x, and from here I got a 2. So what's a common number? Well, let's start with the coefficients. 2 and 5, I've got to have a 2 and a 5. That means I need a 10. I've got to have an x. So 10x is going to be my least common denominator. So that means I'm going to multiply the left-hand side of the equation by 10x and the right-hand side of the equation by 10x as well. Now distributing on the left side, 10x times my first fraction, I'm going to get 10x times 1, which is 10x over 2x. And then I'm also going to get minus 20x over 5x. On the right-hand side, I get 1/2 times 10x, which is 5x. So let's see if we can do a little simplifying. On the left-hand side, 10x divided by 2x becomes 5. That's not an equal sign, that's a minus. 20x over 5x is 4. And on the right, oh, now this got way easy. And I say way easy because now I can simply divide by 5. X is 1/5. And doing a quick check, as long as 1/5 doesn't make any of these three denominators 0, 1/5 is considered a valid solution. Okay, that's going to wrap up our introduction to two different techniques for solving rational equations.